Hello guys, hello world, hello Philippines. Since most of the time I'm vlogging regarding singing and occupational safety and health or other topics and subjects. Okay, but now I really miss talking about you guys regarding one of the topics in chemistry. Okay, so as you can remember, we have the three phases of matter: liquid, solid, and a gas. Okay, and then of the three phases, I am more interested in gas. Okay, rather than the solids and liquids. Okay, because there are a lot of equations involved in a gas phase. Again, it's more interesting because um, in a gas phase, and that's in terms of safety. But now going back to you know, to the principles and theories and equations behind that. Okay, so I have here a piece of paper. I write. Okay, because I miss in my college days. I write here. Okay, so I have 13 topics. Okay, but I will just discuss in an overview manner. I don't have to discuss in detailed fashion because it will take more time for me to do that. Okay, number one, we have the ideal gas law, or what we called in chemistry as a general gas equation. Okay, and then we have the residual property. Okay, so what do you mean residual property? You know that? So I think most of the science courses, chemical engineering or BS can answer this one. Residual property, we have the specific gas constant. Okay, what is the value of the specific gas constant? Okay, number four, we have the universal gas constant and ideal gas constant. So this is the constant used in an ideal gas law equation or general gas equation, right? Okay, number five, we have the molar mass. The molar mass will be equal to the uh, mass of the substance divided by the number of moles of a gas, or number of moles same as the amount of a substance. Okay, and then usually gases we are referring here is monoatomic gases. Okay, like that. Okay, we have the combined gas law. Okay, number seven, we have the Boyle's law, Charles law, Gay-Lussac's law. Okay, and number eight, we have the absolute zero. Number nine, we have the STP at standard temperature and pressure. Number 10, Avogadro's law. Okay, in which pressure and temperature are held constant in that particular law. Okay, Avogadro constant. If you remember that one, you still remember that Avogadro is constant. Okay, 6.023 times 10 to the 23 moles per molecule, like that. Okay, and then we have the Boltzmann constant. Still have to research this one. I forgot the value of this Boltzmann constant. And the energy in ideal gas constant is equals to energy represents in capital E. Okay, capital E, 3 halves in RT, something like that. Okay, going back to number one, we have the ideal gas law. So this means that monoatomic gases behaves ideally. Okay, behave ideally, meaning to say is hypothetical ideal gas. Okay, this ideal gas law okay, will provide us a good approximation of the behavior of the gas under certain conditions because it has limitations. Okay, particularly monoatomic gases at a higher temperature only and a low pressure, something like that. Remember that one? This ideal gas law is applicable for at high temperature and low pressure for monoatomic gases. And in here, for this ideal gas law or general gas equation, the molecular size of the gases and the molecular attraction is neglected. So it's not been considered. Okay? So the movement of the particles are not an issue here. So that's why it behaves ideally. Okay, if that is the case, okay, it is not considered. So it will be considered later on the real gases. Okay, real gases is the opposite of the ideal gas, in which in the real gas, it's being considered there the molecular sizes and the molecular attraction of a gas. Okay, something like that. Okay, so we mean that ideal gas is the non-real gas and the real gas is the non-ideal gas. Something like that. So the real gas also behaves in the equation. I will write the equation. Oh, yes. Wait. If I will talk this too much, it will take more than 5 hours. Okay, like that. So, like that. Excuse me, guys. I have to go there, here. Okay. Like that. I'm here in my bed.